we are going to do first is there are some typos in the first 7 books that sold. It's literally only 7 books. So if you're one of those 7 people, I'm just going to make you aware of some of the typos that I didn't catch the first time publishing. So for number 10, there's going to be some new answer choices. So let's go to that one. The new answer choices, if you want to pause and see that, it would be that for the new answer choices. And then if you don't want a spoiler, you can just wait until after you do it to check if the answer is correct in the video. But if you do want the spoiler, it's G. So what we're going to do first is, hello, Koya. What we're going to do first is just go over arithmetic versus geometric sequences and formulas. So this is going to be on page 49 in the book. And basically the main difference between arithmetic and geometric is, are you adding something or are you multiplying by something, basically? So with arithmetic sequence, you're adding D each time, whatever D is. D is the number you're adding. So even if it looks like you're subtracting, like let's say you have 1, then it would be, I don't know, -3, and then -7. So like each time it looks like you're subtracting 4 each time, but that's the same thing as adding -4. So you still think about it like adding. Like D would be -4 because the number you're adding is -4. So in that case, this would be arithmetic because we're adding the same number each time. So then that tells us that we should use one of these formulas. Now in these formulas, to find the nth term, meaning like the 3rd term, the 4th term, whatever term it is in the list, like for instance, this would be A of 3, where 3 is the little n because it's the 3rd term in your list. This would be A1 because it's the 1st term in your list. That little number tells you what number it is in the list. So you could keep going and find whatever nth term it is. Like you could find the 48th term in this sequence using this formula, and you would just plug in 48 for n. And then the D is always the same. It's increasing, or technically it's decreasing, but you're adding -4 each time, so D would be -4. And then you would know that A1 is just the first number in the list, so 1. So that's how you would find whatever number term it is. And then the other thing that you would need for arithmetic would be the sum formula. So this would be the sum for the whole entire list, like the series, the sum of a series. So if it's arithmetic, it goes by this formula. So n still means the same thing. So if you're saying what's the sum of the first 60 terms or something like that, n would be 60 because it's the first 60 terms. And then you would just plug in 60 for n. A1 is still the first term in the list, so that would be 1. And then you add on A to the 60. So then you would have to plug in 60 here to find A60. So then the geometric sequence, it's pretty similar, except you would have a geometric sequence if you're multiplying by something. And remember, it could be looking like it's division when it really is multiplication just by a fraction. So you still think about it as multiplying. For instance, if you have this as a sequence, you're still multiplying by 1/2 each time. It looks like you're dividing by 2, but still think about it like multiplying. 8 times 1/2 is 4. 4 times 1/2 is 2. So your R in this case would be 1/2 because that's what you're multiplying by each time. So that's what you would plug in for R here. The N is still the same thing, like finding the 40th term in the list. You plug in N for 40 for N. A1 is 8. Same exact thing. So, and then this is just the sum formula that you would use. Now, there's something called an infinite sum. It's very rare that you're going to get this on the exam, but just in case, this goes with a geometric sequence, and the infinite sum formula is this. Basically, the first term in the list over 1 minus whatever you're multiplying by, R. And this only happens, we call it converges, where the absolute value of R is less than 1. So now that we've gone over that, let's go to the sequences questions. So for number 1, it says, Candy Corporate makes gourmet candy. They make 4 different flavored chocolates and 5 different flavored candy canes. Candy Corporate makes a profit of $6.50 on each candy ball it sells. Candy Corporate sold 2,000 multicolored balls in its 9th month of operation and 2,100 multicolored balls in its 10th month of operation. How much profit in dollars did Candy Corporate make on the multicolored balls in its 4th month of operation? Assume that Candy Corporate sales of these multicolored balls follow an arithmetic sequence. So we know it's an arithmetic sequence. So that already tells us which of the formulas we should be using. So I'm going to write those formulas now. So for arithmetic, any nth term is going to be equal to this right here. And then we know that it said that A9, in the 9th month of operation, so A9 would be equal to 2,000. So we know that A, when n is 9, is equal to 2,000. And we know that in the 10th month of operation, so A10, that's going to be equal to 2,100. So in a list of numbers, the 9th term is 2,000, the 10th term is 2,100. They told us it's an arithmetic sequence, so that means we're adding some number D each time. To get from 2,000 to 2,100, we had to add 100. So that means that that's what is equal to D, because D is what we call the common difference, or the number we add each time. So we know what D is, it's 100. Now, to figure out this problem, we would need to also know what, well, we're trying to find out, what is it, how much profit in dollars. So we would need to figure out what A1 is, plug it into the formula, and by plugging all these values into the formula, and then after that we could find out what the 4th month is, like how many balls that they sell, so then we can multiply that by how much profit they have for each of the balls. Someone asked what book I'm using. This is my book that I wrote. It just released on Amazon, Overcoming ACT Math by Sophia Garcia. If you like it, please make sure to leave reviews, because people don't really leave reviews on like good stuff. It's usually only like if they want to complain about something. So it's really hard as a business owner to get reviews. So if you guys like it, please make sure to review it if you've bought it. So let's keep going. So let's plug in the values that we have. So we have, let's say 2,000 is equal to 2,000 is equal to A1 plus 100 times 9 minus 1. All I did was I picked one of the numbers. I just happened to pick the A9 one. So A of n, A9 is 2,000. So that means that n has to be 9. So I just plugged in 9 for n. And I plugged in for D, the number it goes up by each time in the sequence is 100. So now I can solve for what the first term in that sequence is. So that would just be 2,000 is equal to A1 plus 9 minus 1 is 8. So 800, because 100 times 8. So then we're going to subtract 800 on each side. And that's going to give us that the first term in the sequence is 1,200. So in that first month, that's how much they sell. Now, we want to know how much profit on the 4th month. So to know that, we first need to know how many balls that they sell. So we have to find A of 4. So A of 4, if we're using this formula, is going to be equal to A1 plus D to the n minus 1, which n is going to be 4. And we know that D is 100. 4 minus 1 is 3. And then A1 we just solved for, so that's 1,200. And that's all going to equal the 4th term in our list. So now this would just be 1,200 plus 300. So that means that A4 is going to be equal to 1,500. So now that's how many balls were sold in the 4th month. But the profit for each of the balls is going to be $6.50. So to find the profit for the 4th month of operation, we just have to do how many balls times the number of profit, the profit per ball. So it would be 1,500 times $6.50. And when you plug that in, that's going to equal $9,750. So it would be A. Yes, that's correct. For the person that said it's ACT right now, yes. This chapter is sequences, so this only applies to ACT. This is not on the SAT. But we're going to do stuff that applies to both exams on this. Okay, so let's go to number 2. It says, if a sequence is defined by A of n is equal to all that, then what is the sum of the first 4 terms of the sequence? So for this one, I would just start plugging in numbers. So like the first term of the sequence is going to be A1, because remember that's what the n means, what number it is in the list. So the first number is going to be equal to, just plug in 1 for n. So that's just 2 cubed, which is 8. And then do the same thing for the second, and the third, and the fourth. And then add them all up to get the sum of all 4. So that means that A2 is going to be equal to 2 plus 1 cubed, which is going to be 3 cubed, which is 27. And then the third number in the list is going to be A of 3, which equals 3 plus 1 cubed. So that's going to be 4 cubed, which is just 64. So then we have the fourth term is going to be A4, and that's just going to be 4 plus 1 cubed. So then 4 plus 1 is 5, so then 5 cubed is just going to be 125. So now we just need to add all these up. So I'm going to do 8 plus 27 plus 64 plus 125. And when I add those all up, it's going to be 224, so that's going to be J. And for people that need it to go slower, just know I will try to be aware. I know sometimes I talk fast, but some people like it, some people don't. These all get uploaded onto YouTube, so YouTube has an option where you can slow down in the settings the video if you want to, or speed it up if you want it to go even faster. So someone asked, where did the 2 come from? So the 2 here, it came from, I'm finding the second number in the list. So the N talks about what number in the list it is. So if I want the second number in the list, I have to put 2 for my N. My YouTube is the same as this channel, AG Tutoring. There's also a link in my profile if you can't find it. So then let's go to the next one. What is the missing value in the sequence? So to find the missing value, we first need to know what type of sequence it is. It doesn't tell us, so we have to determine that based off of how the numbers are changing each time. Well, this looks like it goes up by 3. So let me test that theory. Up by 3, up by 3. Would that work? Up by 3 would be 5, up by 3, then 8, and then up by 3 again would get us to 11. So it is going up by 3 each time. So the missing value in the sequence must be C. So this is an arithmetic sequence because we're adding a number each time. That's how you know what type of sequence it is. You could have used the formula thing where it's A of n, where is it, like this formula, and you could have done A3, but this is faster. But either way. So then let's go to number 4. It says, given the sequence right here, what is the sum of the first 60 terms? So again, to know what formula you have to use, if you're going to use a formula, you have to determine what's the pattern. How is it changing? So that you know if it's arithmetic or geometric. So this looks like it's going up by 6 each time. Yep, up by 6 would get you to 11, and then 11 plus 6 would get you to 17. So this is definitely an arithmetic sequence. So that means that the formulas we're going to be using are going to be A of n is equal to, and then that's going to be A1 plus dn minus 1, yeah, because arithmetic, and then S of n for arithmetic is going to be equal to n over 2, and then in parentheses, A1, the first term, plus A of n. So if we want to find the sum of the first 60 terms, that means that our n is 60. So S of 60 for n. So I'm just plugging in a 60 everywhere I see n. And then A of 1 just means the first term, so the first number in our list, which is 5. And then A of n, remember we're replacing n with 60, would just be whatever A of 60 is. So to solve what the sum of the first 60 terms are, we need to know what A of 60 is so we can plug it in. We can use this formula here to help us out. So to find A of 60, I'm going to plug in 60 for n in this formula. So A of 60 is equal to, A of 1 is going to be the first term, and then plus, it's going up by 6 times, so D is what number it's adding each time, which would be 6, times 60 minus 1. So this is going to be equal to 5 plus 6 times 59. So then when you do all of that, it's going to be 359 for the 60th term. So now you can plug that in for A of 60. And you could say that this is equal to 60 divided by 2 is 30 times 5 plus 359 for A of 60. And that would just be 30 times, and then that would be 364. So then when you multiply that, you're going to get, let's see, And you multiply that, and you're going to get 10,920. So it would be G. Okay, so then someone asked, what is my opinion on a good SAT score? That's hard to tell because it depends on where you're going to college. So like you would have to look at the average for the college that you're going to. Usually they tell you median scores, so like look at the median, and then if you're at or above that, you're in a pretty good spot. That's what I would consider good. So it depends on the colleges. So then let's go to the next one. So it says number 5, what is the missing value in the sequence? So we have to determine what kind of sequences is this, what's happening before, well, for this one, we don't really have to use the formula, so that's not as important, but we do have to see what's happening each time to find the pattern. So here, let's see, so this is times -5. Yeah, because if you do 75 times -5, that would be 5, carry the 2, so then that's going to be -375. So it's being, you're multiplying by -5 each time. So let's multiply 3 times -5 to get the next term. So then that would be -15. So then it would be A. Someone asked if I prefer ACT or SAT prep. I personally, I prefer ACT, I would say. I prefer the ACT. That's what I took in high school. I didn't take the SAT. So yeah. And then, is this SAT prep? This is ACT prep right now. Sequences are not on the SAT, but we are going to do stuff that applies to the SAT after. So let's go to number 6 for a geometric sequence. This, okay, so we have the 3rd term and the 6th term in the sequence, and we want to know what's A of 12, meaning like what's the 12th term in this sequence. So it's geometric, so that means that the formulas that we're going to be using are going to be, that would be the A of n is equal to A1 times, and then it's R to the n minus 1. And we don't need the sum formula because we're not doing any of that right now. So what this is saying, if like you put it in a list, it would be A1, A2, like the first number in the list. That's what that 1 means. This 2 means the second number in the list. A3, the third number in the list, they told us is 27/2. And then the 4th number in the list we don't know. The 5th number in the list we don't know. But they told us what the 6th number in the list is, which is 729/128. So we have to ask ourselves, it's told us it's geometric, so that means that we're multiplying by something each time. So we have to ask ourselves, what are we multiplying by each time? So let's see, times 2 times 2 times 2, that doesn't get you to 128, times 4 times 4 times 4, that does get you to 128. So that means on the bottom, we're multiplying by 4 each time, because you multiply by 4, then 4 again, and then by 4, and that would get you to 128. So the common ratio, R, the number we're multiplying by, on the bottom, it has to have a 4. And then let's ask ourselves, okay, on the top, what do we have to be multiplying by? It's probably going to be 3. So then let's see, times 3, and then times 3, and then times 3, times 3, times 3, times 3. Yes, that would get us to 729. Sorry, I meant to put like the 3 there. 3 gets us to 729 on top, so 3/4. So we're multiplying by 3/4 every time, and that gets us to this number right over here. So our R is 3/4. So now if we want to find what A12 is, that means I have to plug in 12 for n. And then A1 is what I need, but I don't have it yet, and we'll talk about that in a second. And then I have 3/4 for R, and then I'm going to plug in 12 for my n. So to solve for A12, I now need to find out what the first number in my list is. Well, I can do that by just working backwards. So now, if I'm multiplying, every time I go to the right by 1, I multiply by 3/4. To go backwards, I would just do the opposite. I'm going to divide by 3/4. So if I divide by 3/4 here, 27/2 divided by 3/4, keep, change, flip, so I keep this fraction, multiply, change this to multiplication, and then flip it to become 4/3. I could cross cancel, so this cross cancels to 1 and 2. And you could multiply it out and simplify after if you find that easier. I'm just doing it this way. So then I would get that A2 is going to be 18. So now I'm going to do the same thing. I'm going to divide by 3/4 to get what A1 is. So I'm going to do 18 is the same thing as 18/1 divided by 3/4. So keep, change, flip, keep 18 over 1, change to multiplication, and flip the fraction upside down. And I'm going to cross cancel that out, and that equals 24. So that means that the first term has to be 24. So now I can plug that in here for what a of 1 is, and I could say that I'm going to multiply by 3/4 to the 11th power. And that'll give me what the 12th term is. But you'll see here, you can't just multiply that all out in your calculator. It looks a bit different here. So you have to ask yourself, okay, looking at the answer choices, how can I manipulate this? So it looks like they're using 3s and 2s. So I'm going to say, how can I rewrite this using my power rules to get one of these answers with 3 and 2 being the bases? So I'm going to say, okay, 24 is the same thing. That could be 8 times 3. So now I have a 3. I'm looking for 3s and 2s to be my bases. And I could rewrite 8 as 2 to the 3rd. So that'll help me out. So I'm going to say that this is equal to 8 times 3 is the same thing as 24. So then this would be 2/3 times 3. And then this is being multiplied by, and then I'm going to rewrite 3/4. 3 I can keep, and then the 4 I could say is 2 squared. And I'm doing that because I see that there's 3 and 2s as the bases there. So then this is all going to be to the 11th power. Now I'm just going to use my power rules when I multiply across, after I do power to a power, multiply across to get one of these types of answers right here. So let's start by copying over the 2 to the 3rd power and the 3. And now we're going to do the power to a power rule, which says that if you have this in parentheses and it's all being raised to a power, you can multiply the powers or the exponents. So remember, this is really 3 to the 1 power. We just don't write the 1 in math. So we would multiply 1 times 11, and that's 3 to the 11th power. And then now do the same thing on the bottom. So 2 to the 2nd power, 2, you multiply the exponent 2 by 11. So then it becomes 2 to the 22nd power. So now what we're going to do is we're going to multiply it all across so that we have 2 to the 3rd times, and then 3, this is 3 to the 1st power, remember, we just don't write the 1 in math. And so if we use product rule, we say if we're multiplying between like bases, meaning the 3's are like bases, we have to add the powers or exponents. So 1 plus 11 is 12, and that's all over 2 to the 22nd power. So now what you're going to do is, you can do this a couple of ways. You could cancel out on top and bottom, or most people find it easiest to just use the quotient rule now and say 2 to the 3rd power is a like base with, has a like base of 2 and 2 down here. So we subtract the exponents. So we keep the like base, the 2, and we subtract 3 minus 19, or 3 minus 22, which is going to be negative 19 times 3 to the 12th. And then you can apply negative exponent rule, which says that we're going to just keep this on top, and negative exponent rule says that you just put this on bottom of the fraction bar, but to the positive version of the exponent. So it's going to be 3 to the 12th divided by 2 to the 19th, which is going to be j. So then let's go to number 7. Hold on, let me get water, guys, really quick. Okay, so let's go to the next one. Number 7, it says, given the sequence this one, what is the value of the 60th term? So how's it changing each time? Well, it's going up by 6 because 5 plus 6 is 11. 11 plus 6 is 17. So this is an arithmetic sequence. So that we know that because we're adding by something each time. So that means our common difference, D, the number we add each time, is 6. And if it's an arithmetic sequence, to find the nth term, we use this formula. So a of 1 just means the first number in the list, which is 5. And I'm being asked to find the 60th term in the list, so that means that n has to be 60, because n is just like what number is it in the list. So the 60th number. A of 1, the first term is 5, plus we know D, the number we're adding each time, is 6. And then n we already established is 60, so I'm just going to plug that in for n. And then all I have to do is simplify and solve. So this would be 5 plus 6 times 59, which is equal to, that's going to be 359. Yeah, so then that's going to be A. So let's go to number 8 now. Remember, please like and share this live with your friends who are doing SAT and ACT prep. We're doing ACT right now, but we'll be doing stuff that applies to SAT after as well. So then let's go to number 8, which says, every December 31st, Sarah deposits $2,000 into her savings account. How many years will it take for Sarah's deposit to sum to $26,000? Hold on, someone said the last one is wrong. Did I, no? Let me check the answer key, hold on. Nope, it's all good. It's A. So this is the ACT for people saying, why aren't you multiplying it out? Because you could use a calculator. You just use that in a calculator, and then you have what the answer is. So let's go to number 8. So every December 31st, Sarah deposits $2,000 into her savings account. How many years will it take for Sarah's deposits to sum up to $26,000? Okay, so every year she's putting $2,000 more into the account. So this is an arithmetic sequence because it's adding $2,000 each year. So if we want to find out the sum of an arithmetic sequence, it's going to be S of n is equal to n over 2 times a of 1 plus a to the nth term. That's how you find the sum. And the formula for finding a of n, like the nth term, whatever number it is in the list, is n. If it's the 6th number in the list, n would be 6, a of 6. This formula would be a1 plus d to the n minus 1. I'm glad you guys are enjoying the live. Thank you for being so kind. So then let's go and now use this information here. So D, the number that it's going up by each time, is going to be equal to that $2,000. $2,000 is what they're at. Oh, wait, sorry. No, it's not. It's what they deposit at first. Sorry. So that's the A1. Whoops, I lost my mind for a second. So that's A1. A1 is 2,000. So then let's see what other information. We know S of n. So S of n is equal to 26,000. So we can plug that in for S of n, and this would be 26,000 is equal to, and we're basically trying to find out what n is, because n will tell us how many years have passed. So n over 2, and then times A1, we know, is 2,000, plus, and then we need to know what A of n is. And remember, n is what number it is in the sequence. So then let's see. Oh, wait. Or actually, this is the long way of doing it. Why am I doing it this way? Sorry, I'm just so used to writing the formulas and doing it. There's a much easier way to do this. We could just say 26,000 divided by 2,000. We could say each year it's 2,000. How many years have passed? So then it's going to be 13. G. So then, yeah, sorry. It's robotic at this point because it's never that easy. So it's the first time that I do it, I usually do the harder way because it almost never comes like this on the ACT. So then let's go to number 9. Okay, hold on. Guys, hold on. I'm trying to block people because if you're going to be rude. So let's go to number 9, and it says, Josefina is saving up for a new video game console. Once she begins saving, she wants to save $10 during the first week, $11 during the second week, and $12 during the third week, saving $1 more each week until she saves $17 during the 8th week. She will then start over saving $10 during the 9th week, then $11 during the 10th week, saving $1 more each week until she saves $17 during the 16th week. She will continue this pattern for 1 year. What is the total amount of money Josefina will save in 1 year? Note, there are 52 weeks in a year. This is for ACT prep, not SAT prep for the people asking. Guys, if it's okay, to get things wrong once in a while. I was doing it the hard way, a longer way, and then I realized, okay, yes, I saw your comments, and I was like, oh yeah, there's a much easier way to do this. So I did it that way. It's okay every once in a while to, not think things through the easiest way each time. You're not going to get it the first time every single time, even teachers, and I've been doing this for years. So, chill. And you will get blocked if you're being rude. So then let's go to this one. Okay, so what is the total amount of money she will save in 1 year? So she's saving $10 for the first week, $11 for the second week, $12 towards the third week, and saving $1 each week till she saves $17. Okay, so I would just start adding this up. This one would be an easy one too, where you could just kind of use logic and not even like the formula stuff. So you could say you're going to do 10 plus 11 plus 12 plus 13 plus 13, it's going up by $1, plus 14, plus 15, plus 16, plus 17, until you get to that 17 that they said, and that's just for the first 8 weeks, right? So that's for the first 8 weeks, and you would know, hey, that's how much she has saved during those first 8 weeks, and then you could do, then you're going to do, like, that happens every 8 weeks, right? So then whatever this equals to, you would just do that every 8 weeks. So if this is all equal to, if you plug it into the calculator, that would be 108. So we're going to do 108 for the first 8 weeks and then every 8 weeks after that. So there's 52 weeks in a year. So it would be 52 divided by 8. And then that's going to be equal to 6.5, which is the same thing as 6 and 4/8, 6.5, which if we unsimplify it is 6 and 4/8. I'm going to show you why I'm doing this now instead of writing 6.5. So that means that we're doing 6 and 4/8. So then that would be 108 times 6, because there's 6 groups of 8 weeks. Plus, the reason I did the 4 here is because you know that there's going to be 4, like she's only doing 4 of these out of the whole like 8 that she was doing before. So like only 4 weeks is happening. So it's only the 10, the 11, the 12, and the 13. I mean, you could like see that like with the 1/2 thing, like half of 8 weeks is 4, but like most people, this would be easier to see. So then what we're going to do is we're going to say we're going to add those first 4 weeks. So that's supposed to be 13. I'm running out of room. So this says 10 plus 11 plus 12 plus 13. So then when you plug that into the calculator, it's going to be 694. So that would be D. Okay, so let's keep going. So number 10 says that we have this sequence. What is the 43rd term in the sequence? Again, ignore these answers. This is an old book with typos. So we have the 43rd term in the sequence. What's happening each time? Well, this is going up by 3 each time. It looks like, yeah, because up by 3, this would be 8, and then that would go up by 3 to get you to 11. So this is an arithmetic sequence. So remember, the formula would be the nth term, a of n, is equal to a of 1 plus d times n minus 1. And n is the number like of term that it is in the list. So like 2 is a of 1 because it's the first term in the list. And 5 is a of 2 because it's the second number in the list. So like they're asking for the 43rd term, so that means we're looking for a when n is 43, a of 43. So then the first term in the list is 2, so we can plug that in for a1. Plus d is the number that it's adding each time, so it's adding 3 each time. So that means that d is 3, and then we know n is 43, so 43 minus 1. So now we're just going to solve this. So this is going to be, let's see, that's going to be 2 plus 126. And then we would just have to do that's 128, so it would be G. Okay, so let's keep going. Number 11 says the value of the infinite sum of all of this is. So let's go to, okay, hold on. There's someone here that's being annoying. Okay. So then let's go to number 11, the value of the infinite sum. So this is the formula I was talking about at the beginning, where the infinite sum formula, where it's equal to the first term, a of 1 over 1 minus r, where the absolute value of r is less than 1. So let's see. In this case, to go from one to the other, I think this is just 1/2. They're multiplying by 1/2 each time. So times 1/2, and then times 1/2 each time. So multiplying by 1/2 each time, so that's r is the number you're multiplying by, so 1/2. So the infinite sum is going to be equal to the first term, 7, over 1 minus 1/2. So that's going to be equal to 7 over 1 minus 1/2 is just 1/2, and then that would just be equal to 14, so C. And yes, you're able to use a calculator on the ACT exam for the person that asked. So let's go to number 12. Thanks for sharing the live, guys. And remember, if you need an ACT or SAT prep book, I have both. This happens to be the ACT one. It just came out on Amazon. It's called Overcoming ACT Math by Sophia Garcia. So let's go to, someone asked, I'm going to answer a question really quick. Someone asked, when should I start studying? Ideally, I say give yourself at least 2 months, but I have in my books like different study plans that you can do if you're cramming. Like if cramming is considered like you have 1 week or less, and then like up to a month, there's a plan for that, and then for 2+ months, it tells you exactly what to do in the book. Someone asked the name of the book again. This one right here, ACT Math. So if you're interested in this, it has a diagnostic test at the beginning, a review test at the end that you do a couple days before to remind yourself of all the most important stuff. And there's 9 review quizzes throughout, plus a chapter on each topic, because like you need to be reminded, like none of the test prep books that I've found out there that are good, or like even any, have review quizzes, and like you guys do a chapter and you forget it like the next week or something. So it's not really helpful unless you're doing the quizzes and stuff periodically. So that's why I made this book. So let's go to number 12. Number 12 says, what is the 100th term for this sequence right here? So look at the sequence, look at the pattern. So it's going XYZ, XYZ, XYZ. So every 3, it's changing to like repeat the pattern. Or like, I shouldn't say changing, repeating the pattern is what I mean. So it repeats every 3. So if we're talking about the 100th term, so let's do 100 divided by 3, because we're dividing it into these groups of 3. So then that's going to be 33, remainder 1. So it's going to repeat 33 whole times, and then the remainder tells you how many you're going into the repetitive sequence. So you do it all over 33 times, XYZ happens 33 times, and then you have to stop and start the sequence again, and you're only going over by 1. You're going 1 to the next term, so it would be X as the one there. So like for these, what you do is you basically divide by how many, like how the pattern's repeating every 3, and then the remainder is what's interesting and what like you need to find out what the whatever term it is, in this case the 100th term. So then let's go to number 13. So number 13 says a rabbit breeder's rabbits quadruple in population every 4 years. If the rabbit breeder started breeding rabbits 16 years ago, and there are currently 65,536 rabbits, then how many rabbits did the rabbit breeder have when he or she started? Okay. So let's see, I'm sorry, let me get water really quick. Okay, so this number, the 65,536, that's going to be the sum of the sequence, like how many all of are all there when you add all the terms up. So this says that it happens every 4 years, they quadruple, and you want to know, so that would be, so you have like the first term, A of 1, that we're trying to find how many they had when they started, and then every single time it's going to quadruple, meaning we're going to multiply by 4, so that means that R is equal to 4, because R is the number you multiply by each time, and if it's 16, so 4 groups of 4 years get you to 16, but you had to start with a first term, so you're doing like four times that you're quadrupling after the first term, so you're really looking for A of 5. A of 5 as what's going to help you, because you're finding, because you have S, would be S of 5, so then, hold on. That would be S of 5, so then you have to find A of 5. Sorry, I'm confusing myself. So this would be S of 5, the sum of the first 5 terms. But you're going to need A of 5 eventually, because that's part of the formula. So S of 5, the sum of the first 5 terms in that sequence, is going to be equal to A1 times R to the n minus 1. This is a formula that you memorize, and we know that R is 4 because R is the number you multiply by each time, and we're solving for what A of 1 is. We know that S of 5, the sum of the 5, is going to be 65,536, and that's going to be equal to the first term that we're solving for times the number we multiply each time, 4, to the n minus 1. We know n is 5, so 5 minus 1. So then we have 65,536 is equal to A1 times 4 to the 4th power. So now all we have to do is just do 65,536 divided by 4 to the 4th power, and that gives us the first term in our sequence, A of 1, which is how many rabbits they had when they started. So let's do that. Remember, you can use a calculator on the ACT and on the SAT for half of it, but you wouldn't be doing sequences. So then what we're going to get is 256, which is D. So let's go to this one. If you guys are having trouble with this, don't worry. This isn't like huge on the SAT. That's why it's towards the end of the book. Or on the ACT, I mean. That's why it's towards the end of the book. Like, you might get a question on this. You might have the whole exam where you don't even have a question on sequences. So then, where did you get the 5? Because it says that every 4 years it's quadrupling, so you had to start with a first term, A of 1, and then that means that to get to 16 years, you had to have 4 groups of 4. So you were multiplying by 4 different times after the first term. So that would get you to A of 5, the 5th number in the list. So then for number 14, which of the following could represent the sequence right here? Okay, so this is just like, you could just plug in the numbers for n. Like, this would be n is equal to 1, like the first term of the list would be 4, and then this would be n would be 2, and then you would have to get for A of 2, 10. So like, this is the first term, A of 1, this is the second term, A of 2, this is the third term, A of 3, so on and so forth. So you could just start plugging in. So let's start with the n being 1 and the A of 1 being 4. So we could say that 4 is equal to 1 plus 6. No, that doesn't work, so it can't be that one. So let's try this. We could say 4 for A of 1 is equal to 2 to the 1 plus 1. That does work, but we have to keep going to make sure that it's definitely that one. Let's try another term in the list. So let's try the second term, 10. So 10 is equal to 2, and then it would be to the n plus 1, so n would be 2 in that case, so 2 plus 1. So it says that 10 has to be equal to 2 to the 3rd. That's not true, so it can't be that one. So then, let me just fix this really quick. Then for the next one, let's do 4 again. So 4 is equal to 2 times 1 for n plus 2. That works, but let's keep trying with the 10 now. So let's say 10 is equal to 2. 10 is the second term in the list, so n is 2. Plus 2, that's 4 plus 2. That does not equal 10, so it can't be that one. So let's try J now. 4 has to equal to 1 squared plus 2. That's not true, so it has to be K, but let's just check. 4 is equal to 2 times 1 squared plus 2. So that's 2 plus 2 equals 4, so that works, but let's check with the 10 just to verify and prove it. So then 10 is equal to 2 times 2 squared plus 2. That's 8 plus 2 is 10. Yes, so it's K. Okay, let's go to number 15. So number 15 says, Isabella wants to watch 7 fewer minutes of TV every day. If she watches 400 minutes of TV on the first day, then on what day will she watch 204 minutes of TV? So, let's see, watching 7 minutes fewer each day. So we're going down by 7 minutes each time. So this is an arithmetic sequence where we're adding -7. Because remember, even if we're technically, if you look at it and you're like, oh, you're subtracting 7, you still have to think about it for the formula sake that you're adding a negative number. Because that's the same thing as subtracting. So D would have to be -7. Now, we know that the formula for an arithmetic sequence is A of n is equal to A1 plus D times n minus 1. So then we want to know if she watches 400 minutes of TV on the first day, so that means that A of 1 is equal to 400 minutes. What day of TV will she watch 204 minutes? Or on what day will she watch 204 minutes? So a of n, we're solving for n, and we know that a of n is equal to 204. So we would just plug in the values and solve for what n is. So this would be equal to 204 is equal to, and then 400 is a of 1 plus -7 for d times n minus 1. And then we would just solve for n, and that tells us on what day, because on the first day, when a is 1, it's going to be 400 minutes. On the second day, it's going to be 7 less than that, and that would mean that 2 has to be n. N tells you what day it is in this context. So then let's just solve this. So we copied down everything over here, and then we have to distribute the -7 to each of the terms in parentheses. So this would be -7 times n, which is -7n. -7 times -1 is +7. So then we're going to say, okay, that's 204 is equal to 400 plus 7 is 407 minus 7n. So then we're going to subtract 407 from each side. And when we subtract 407 from each side, we're going to get -203 is equal to -7n. Then we're going to solve, we're going to get n by itself by dividing by -7 on each side. So when we do that, we get that n is equal to 29, so it should be B. Okay, so let's go to number 16. So it says, given the sequence right here, what is the sum of the first 14 terms rounded to the nearest whole number? So let's see, let's see what's happening here. So it looks like it's just being multiplied by, what would that be? Multiplied by 1.5, no, negative, it would have to be a -1.5. Yeah, so they're multiplying by -1.5 each time. So r is equal to -1.5. We know it's geometric because that's when you're multiplying by something each time and to get to the next number. So we use this formula, S of n is equal to a1 times 1 minus r to the nth power over 1 minus r. Now we know r is equal to -1.5, so we could plug that in there, and we also know what a of 1 is, the first number in our list, which is 3. So that means, let's see, if we want to find the sum of the first 14 terms, it would be s and n would be 14, sum of the first 14 terms. And then 3 is the first term in our list, a of 1, times 1 minus, and then it's going to be r is -1.5 to the 14th power. And then we're going to say that this is all being divided by 1 minus whatever r is, and r is -1.5. And then now we just have to solve this. You can put this in your calculator because it is the ACT. You get a calculator the whole time. So for the math section. And then so that's going to be -349.115 yada yada yada. So that would be closest to F when you round to the nearest whole number.